Hello, good morning to all. My name is Tulasi Mahesh. My registration number is 21 BCE 5144. Today I have come up with a new topic called Modern Computing Devices and Turing Machine. This comes under the subject Theory of Computation. Now we will discuss what are the contents. Basically we are discussing about this topic. Okay. Um, Contents like generally we will discuss about what is a modern computing device and what is a Turing machine, how does the Turing machine work, and in which manner these two like modern computing devices and Turing machine are interrelated. We will see elaborately here. Like basically what is the modern computer? Like modern computing device or there's nothing but electronic devices. They are designed to perform our make our activities easier and to perform them quickly and efficiently. These devices use various types of processors, memory storage, and input output devices to store the data, store the information, and execute the programs and all. These devices have evolved significantly over the years. They became more powerful, effective, and compact. Okay. Examples of modern computing devices. I have taken here only three examples that are like very familiar with them. Like personal computers generally we use and smartphones everywhere we will carry and we will work in them, and gaming consoles. We kids like play games and regularly. Now we will discuss about personal computers. Personal computers are the most common type of computing devices. They are used by individual students, teachers, and professionals, business magnates, and all. These personal computers contain central processing unit, memory storage, input output devices, and hard drives, and many more. Like PCs can run various operating systems such as Windows, Mac OS, Linux, and whatnot. Smartphones are mobile computing devices. They are designed to use primarily for communication, like just for talking and entertainment, like YouTube and all productivity. They typically include a touch screen, cellular connectivity, and a range of sensors and cameras for input. Like in smartphones, we can use a variety of apps, including Microsoft Teams, social media, games, not only studies but also these kind of and entertainment programs. Now, gaming consoles such as Sony PlayStation. Like we use joystick and all, and we use Microsoft Xbox. These are famous kind of gaming consoles. These are especially computing devices designed specifically for gaming. That's it. Like we cannot use them for any other purpose. And these includes more powerful kind of processors and dedicated graphics, and these graphics contain very high quality products and all, and typically connected to a TV or monitor for in output. Like we can connect them for getting an output. Okay, gaming consoles. Relation. Now we will get into the actual topic, like relation between. Well, what is the main relation between modern computing device and a Turing machine? We will look into that. Modern computers and Turing machines share many of the fundamental principles. Okay, whatever we will see now. Turing machine is a theoretical concept and not a physical device. It is used as a model for designing and understanding the works of a modern computer. The basic components of a modern computer, such as CPU, memory, and storage, all are devised to perform functions that are similar to a Turing machine. Yeah, you are going to understand this. For example, CPU is devised to execute the instruction, which are analogous to the rules that Turing machine follows when manipulating symbols on a tape. Like generally, what we are trying to say is CPU, whatever it is doing in a modern computer, is equal to the Turing machine process, whatever it is doing in manipulating the symbols, just like a tape. The memory of a modern computer is used to store the data and instructions that are used by the CPU. Similarly, in the same way, Turing machine contains a tape and that is used to store the symbols that are being processed by the machine. Like generally, we use this Turing machine to validate a string. Okay, like generally, this string is accepted by the machine or not. Okay, And overall, while modern computers are much more complex than the simple Turing machine, and they're still based on the same fundamental principles and ideas. Like they didn't change any ideas whatever they are following before, but comparatively, Turing machine is less complex and like just like simpler when compared to the modern computers. Okay, yeah. What is a Turing machine? Now we will get into the topic, actual topic. What is the Turing machine? Like Turing machine is a hypothetical computing device, like introduced by English mathematician and logician Alan M. Turing, and based on his name in honor, they named this machine as Turing machine. A Turing machine is an abstract computational model that performs computation by reading, writing, and erasing to an infinitely long tape. Now, we have come across a truth that the tape might be any kind of length, like infinity length. Turing machine is used to study the properties of algorithms and to determine which problems can be solved by the computers and which problems cannot be solved by the computers. Yeah, we can see Turing machine is used to study the properties of the algorithms, and it can vary that computers can solve only some problems, right? Like it cannot solve every problem. That will be determined by the Turing machine, by the usage of this Turing machine. The Turing machine can read only one symbol at a time. We cannot like if you wanna test the string, we cannot test the string like in a single manner, like in a once in a time. Okay, just that Turing machine will read only one symbol at a time, and as per your instructions it will move left or right, and at one time it will complete the length of the string like tape, and it decides its next action based on the present state symbol it is reading. Okay, have you understood that? Differences between FSM, PDA, and Turing machine. We all know that FSM is nothing but finite state machine, PDA is nothing but push down automata, and Turing machine. FSM has only single data structure input string. Okay? Note, note this point. PDA has two data structures, input string and a stack. We all know that PDA uses the concept of stack like for validating the string, and Turing machine has a data structure called tape. Okay, now you can understand what are the differences between FSM, PDA, and Turing machine. Based on their differentiated by the data structures primarily, and a Turing machine consists of infinitely long tape which has been divided up into cells. Okay, each cell contains an alphabet like what based on your language it can be A or 0 or anything based on your language, or even an empty space, and it is nothing but a blank. It is represented by capital B. Like note these points. Okay, above one cell of the tape is a head which can either move left or right and can read the symbols written in the cells. Like in this tape, there will be a one head symbol pointing to one cell. In that cell, there can be any kind of alphabet like A or one or something else. That represents we can the Turing machine is reading at that particular cell. That's it. Like it symbolizes or it indicates whichever symbol is gonna read. Initial configurations and operations can be performed on the tape. Yeah, you can see here the input string is given as AAA, ABA, and BB, and AAA. This is nothing but input string whatever we are gonna test. And the remaining space after the rightmost A, you can see some of the blank spaces. These blank spaces go up to infinity because we know that the length of the tape is infinity. The string is only of limited length, and the remaining spaces are gonna blanks. Okay, read write update symbol belong below the tape head. We can move tape head one step. Yeah, this is the main point. One can understood that the tape gonna change only one step ahead or like right or left. That's it. Like it cannot skip one and like it can go two steps or three steps directly without reading the middle one. That is not gonna happen here. Okay, blank symbol is used to fill the infinite long term like I have said it before. Yeah, this is the model of the Turing machine. This is nothing but a tape, and read or write symbols are there, and in the cells we can represent that a1, a2, and so on, an and b up to a limited, like here five elements, that's it. Here one is representing the head. We can say that the Turing machine is reading that particular b part, that's it. And we can say that read or write head, this is nothing but read or write head. Like whatever operation is going to happen, that will be happening only at that particular point to which the arrow gonna head now. Okay. uh, this is the main topic in the Turing machine concept. Okay, seven tuple definition. A Turing machine is represented by seven tuple definition: q, t, b, and summation, sigma, q naught, and f. Q naught, we know that it is the initial state in the Turing machine, and capital F is gonna be final state, and capital Q is the finite set of states, like whatever states involved in the Turing machine, that gonna be defined, determined in the capital Q set. T is the tape alphabet. Like the tape is generally given by capital T symbols, which can be written on the tape. Capital B is the blank space, as I have said already, and summation is the input alphabet. Like whatever the input we are taking in the tape, like cell part, that will be represented by the summation. And sigma is nothing but a transition function that maps accordingly, and depending on its present and previous state, the alphabet pointed by the head pointer, I have said it before, head pointer, it will move to the new state, change the tape symbol, and move head pointer to either left or right. Okay, it can go one step either left or right, that's it. And q naught is the initial state, f is not a final state, it is a set of the final states, because any machine can have more than one final states. Okay, if any state of f is reached, then the input string is accepted, otherwise it is rejected. Okay, done. And now, transition and Turing machine. Like first symbol is the symbol in which the tape head is initially pointing. That's it. Okay. The Turing machine works like it starts from the extreme left and it moves to the rightmost part. And the second symbol of arrow is a symbol that replaces the current symbol. Okay. Here we can see A. A tends to B, comma capital R. A comma B are the alphabets, and capital R represents to move right direction. Okay, if there was a capital L, then it indicates that to move left direction. And small a is representing a symbol to read and symbol to write, small b. Okay, example of a Turing machine. Like here we are gonna discuss about a simple language. L is 0 power n, 1 power n, where n greater than or equals to 1. Here we are gonna check one string 0011, and we have to say this satisfies the language L or not. Let us see how the Turing machine works for 00 and 11. As we know that the pointer starts from extreme left after the blank position. Okay, here the first element is 0 in our string, which are gonna test. Okay, so the initial state is q naught and it is represented by 0 here. Okay. Yeah. For the easy understanding, we are representing the first element as like underlined one. Okay, then it will move to the state q1 and x will replace 0. Like just we will discuss. First of all, we have identified it as 0. Our basic task is, if we find 0 in the initial state in the first, basically, then we have to change it to capital X, and we gonna uh, ignore the other zeros until we reach a 1. Okay, if we reach 1, then we have to change it as capital Y, and we have to check for 0 again in the string, like in the tape, based on the movement either left or right. Okay, until every 0 converts to x and every 1 converts to y. If both the numbers are equal, then the string is accepted, otherwise it will be not accepted. And in the middle we can represent it as capital L or capital R based on the blank spaces movement and all. Okay. Yeah, here it is seen that now it will change its state to q2. Okay, and y will replace 1. Like if we get 1, and it will be changed to capital Y, and it will move left so that it can detect another 0, so that it will be converted again to x, and it will go on further like to detect 0 and 1 based on the language we are given. Okay, like it will work in the same way, like just it will enter to q3 q4 based on the length of the string and all. Okay, capital B represents the blank space, and after that every string is accepted, like every element is checked and changed accordingly. Then the halt option will be there so that we can stop and the string will be accepted. Okay, and now, yeah, this is the transition function for the given example, and these represent q0 q1 q2 q3 represents the states, and 0 1 capital X capital Y capital B represents the states, like elements whatever there are in the cells of the tape. Okay, here capital Q represents the set of the states, and capital T represents the tuple conditions, like tape conditions. Summation represents the language, like, okay, 0 comma 1 here, and yes, q3. Here we have only q3 as a final state, not many. This is how the Turing machine works. Here both the zeros and ones are converted to x and y. The length of x and y is same, so that we have said it is the string is accepted by the concept of Turing machine. Okay, I hope you guys are able to understand by the explanation. Thank you for giving this opportunity, like to discuss a concept about the Turing machine and modern computing device and how both are related. Okay, thank you.